Okay, good morning, everybody. Hope you all had a good break. So today, we've already talked about multiplicity. We've already talked about end behavior. And now we're just going to put all that together to make a sketch of a graph. So if I give you an equation, you should be able to sketch a graph. And remember, if you get lost or confused, you can always use Desmos to help you figure that out. So let's go ahead and get started. I have the notes down here. I went ahead and that's what I'm going to be using here. So we're going to talk about two different forms. And we've already talked about these forms when we talked about quadratics. One is standard form. And so here we have an example of standard form. Now, standard form does not have to be to the second power. It could be to the third power, the fourth power, the fifth power. So if this is to the fifth power, then usually you have a fourth power term, a three power term, second, first, and then a constant. And the number on the outside is your y-intercept. Okay. Now, factored form, what's nice about factored form is it tells you the solution. So it tells you where it crosses the x-axis. So these are two different forms, and you should be able to graph from either one. And so the instructions are here on what to do. So how do you find the degree of both? So to find the degree of standard form, we just look at the highest exponent, usually in front. To find the degree of factored form, we're going to look at all the x's, so x, 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 and then add those up. And then to get the leading coefficient, you just look at the number in front that's with the highest degree. Usually it's the first one. And then here, you could multiply everything out to get the standard form. That's going to take a while in most cases. So instead, you just look at the a term and then multiply together what's in front of each x. And that'll tell you the leading coefficient. And so a nice little table about end behavior that applies to both. If it's even degree, but a positive leading coefficient, well, then it goes up and up. So up on the left, up on the right. If it's even degree, negative leading coefficient, we go down and down. And remember, the way we write that is as x goes to infinity, the function goes to negative infinity. As x goes to negative infinity, I should say this one on the left, as x goes to negative infinity, the function goes to negative infinity. And as x goes to infinity, the function goes to negative infinity. So that's how you're going to write that. How do you find the zeros? Well, you have to factor it first. If it's in factored form, it's already factored for us. Multiplicity, we've already talked about. Remember the behavior. If the multiplicity is even, then it looks like this. And if the multiplicity is odd, then remember that kind of makes a little, I guess you could call it a squiggle. It does cross. And so let's go ahead and start. And so what I have on the next page is an example. And we're going to start with standard form. So standard form, I would say the degree. Well, the degree is 3. And remember, all we really care about the degree is whether it's even or odd. Well, 3 is odd. What's the leading coefficient? Well, the leading coefficient is 2. And 2, is that even or not even? Is that positive or negative? That is positive. So the end behavior, and you can flip over and look at the table if you want, but remember, If it's a leading coefficient that's positive, that means it opens up on the right. I just did down, I'm sorry. So if the leading coefficient's positive, it opens up on the right. And if it was negative, it would open down on the right. And then odd means it does the opposite on the left, so it's going to go down. So it's going to go down and up. Now, if you wanted to, you could use that table that what is odd positive. Let's go see. I already know odd positive is going to be down and up. Let's see though. So odd positive is down and up. So you could think of it that way too. So remember, the way I would write that for this part, I would say as x approaches the left, the function, which is called f of x, goes down. So I would say negative infinity. And that would be for this one. And then for this one, I would say as x approaches the right, the function, which we call f of x in this case, the function goes up. So I would say it approaches positive infinity. Now, what are the zeros and x-intercepts? This is when it gets to be a little trickier, because how do you find the x-intercepts when it's in standard form? You could go find them by graphing, but I'm going to show you that you could actually factor this. So I'm going to copy it down. And we're going to spend the next 2 class periods on how to factor a higher degree polynomial. Higher degree, what most people mean by higher degree is anything bigger than a 2. So it's to the 3rd power. There's 3 solutions. So there should be 3 factors. So when I look at this, and this is the first type of factoring, there's a GCF of x. So I take out the x, and that leaves 2x plus 11x plus 15. And then this is I forgot my square. This is a quadratic. They didn't really leave me much room here, but this is when I would take 2 times 15, which is 30, and put the 11 down here. So what multiplies to 30 but adds to 11 would be 6 and 5. And so then remember, you would do x with the 6, x with the 5, but then you divide them both by the leading coefficient of 2, and then 6 divided by 2 reduces to x plus 3, and then you slide the 2 in front, and then bring down the x. So this is borrowing space for multiplicity. So that would be factored form. And notice that's what this is up here. This is a whole different function. I kind of wish they would have named it like g of x. But now to get the solutions, I would say 0. I guess I'll put it here. For positive 3, I would say negative 3. And then for 2x plus 5, if you set 2x plus 5 equals 0 and you solve for x, you get negative 5 halves. So if you said 2x plus 5 equals 0 and then solve for x, you get negative 5 halves. So a lot of this is review so far, but the next class period, we're basically going to be practicing how do you find the GCF. Multiplicity, when I look at this, every single factor does not have multiplicity. It's just, I guess you could say multiplicity of 1. So you would say x equals 0 multiplicity of 1, x equal -3, multiplicity of 1, and then x equals -5/2, multiplicity of 1. Now, what is the behavior at each zero? Remember, when the multiplicity is 1, that's when it goes straight through. So I'm just going to put it goes straight through each zero. Now, what's the y-intercept? It's pretty easy in this case. It's the number that's on the outside, and there is no number, so it's going to be 0. So the y-intercept is 0. And then if you wanted to make a table for extra values, what they're saying, and I'm not going to do that part, but you can just plug in, say, like -5, -4, -3, -2, and so on. So that's what you get from standard form. Now, factored form, it gets to be a little trickier. So what is the degree? The notes suggest it's best to write this out. So actually, I guess that would be easier. So if I write this out, it would be f of x is -5, x plus 3. And then what they're suggesting in the notes is that because 2x minus 1 is squared, you write it down twice. I guess this would be easier. And then because x squared minus 4 is to the third, you write it down 3 times. Do I have room here? I think I have room. I guess. So to find the leading coefficient, you would take -5 Oh, I guess we should have done the degree, but we'll go ahead and do the leading coefficient first. We'll do -5 times 1 times 2 times 2 times 1 times 1 times 1. In other words, to find the leading coefficient, you take the a term times the number in front of each x. So 1, 2, 2, 1, 1, 1. And we multiply that out. Let's see, that'd be, I don't really need to multiply by 1, so I'll ignore those. -5 times 2 is -10. -10 times 2 is -20. So the leading coefficient is -20. And really, I just need to know that that is negative. Now for the degree, you look at the x's. And so I have x. I have an x. I have an x. I have an x squared, an x squared, an x squared. So all I did was I said I have 1x, 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 an x squared, an x squared, an x squared. You may be thinking, why didn't you include the 2? Well, the number out front is just the leading coefficient. We're just looking for the x's. So if I do multiply this out, I got 1 plus 1 plus 1 is 3, plus 2 is 5, plus 2 is 7, plus 2 is 9. So that'd be x to the 9th. So I would say degree is 9. So degree is odd. So you may remember, if the leading coefficient is negative, that means it opens down on the right. And if it's odd, it does the opposite, so it's going to open up on the left. So I would say for this one, as x approaches negative infinity, the function goes to positive infinity. This one, as x approaches infinity, the function goes to negative infinity. As x goes to the left, the function goes up, so it'd be f of x approaches infinity. And then as x goes to the right, for this one, the function goes down forever. Now, what are the zeros? It's so much easier when it's in factored form. So, I mean, you could look at this if you want. I would just look at this, and we really should go ahead and factor x squared minus 4. X squared minus 4 factors into x plus 2, x minus 2. So this really, what I'm saying is x squared minus 4 is difference of two squares. So it's going to be x plus 4, x minus 4. So I could write that as, I'm sorry, x plus 2, x minus 2. So that's going to be x plus 2 to the third, x minus 2 to the third. It's very sloppy. So what are the zeros? The zeros would be for x plus 3, negative 3. For 2x minus 1, it'd be, if you set that equal to 0, you get 1/2. For x plus 2, you'd get negative 2. And for minus 2, you'd get positive 2. Now the problem is I only listed 4 zeros, but it's to the 9th power, so I need 9 zeros. So some of these are duplicates. So that's when we list multiplicity. So I would say x equals negative 3. How many times did that happen? It happened once. X equals 1/2. How many times did that happen? Twice. X equals negative 2. How many times did that happen? 3 times. And then x equals 2. How many times did that happen? 3 times. Oh, I wrote that way up there. So if I count these, they should add up to 9. 3, 6, 2, 1. 3 plus 3 is 6, plus 2 is 8, plus 1 is 9. So this is an example of a function where all roots are real, none of them are imaginary. So what's the behavior at each zero? And just for sake of time, I should probably move on to another example. But for this one, it's going to go straight through because it's just a 1. For here, it's going to bounce. So I guess I could put at negative 3. It's going to go straight through. For 1/2, because it's 2, remember anytime it's even, it does a bounce. What I mean is at 2, that's what I mean by bounce. It could be upside down. And then for x equal negative 2, remember when the multiplicity is odd, it does a, I guess you could call it a squiggle. I don't think I spelled that right, but a squiggle Negative 2 means it does something like that. Could be upside down. Okay. Now, what is the y-intercept? Now you would have to look at this term. We'd have to take 3 times negative 1. It's actually easier. I would take negative 5 times 3 times negative 1 times negative 1 times negative 4 times negative 4 times negative 4, and that would be my y-intercept. So I would just take negative 5 times 3, negative 1, negative 1, negative 4, negative 4, negative 4, and that should be my y-intercept. So if I multiply that out in my calculator, negative 5 times 3 times negative 1 times negative 1 times negative 4 times negative 4 times negative 4, I get 960. That was a quick summary. Let's go ahead and talk about how to graph. Okay, we're doing good on time. So when I look at this, it's in factored form. So the first thing I would do is I would recognize that the solution for x minus 1 is 1. The solution for x plus 2 is negative 2. And the solution for 3 is negative 3. Okay. From there, I would look for the degree. The degree, remember, would be x, x, x. So it'd be x to the third. Which is odd. And the leading coefficient would be 1, actually negative 1 times 1 times 1 times 1. So negative 1 times 1 times 1 times 1. Which is negative 1, which is negative. So what I know is it's going to open down on the right, but because it's odd, it's going to open up on the left. Furthermore, because all of these have exponent of 1, it's just going to go straight through. So I know it's going to start up here, come down, come through, come back down. So there's nothing fancy here. And I'm not going to worry about the y-intercept. But if you wanted to get the y-intercept, you would just take negative times negative 1 times 2 times 3. Oh, that's right. So that'd be negative times negative 1 is 1, times 2 is 2, times 3 is 6. So if you wanted the y-intercept, it's going to come up here. You don't really need that for me. So it's going to start up here somewhere. It's going to come down. It's going to go through here and go back down. So sometimes it is nice having that y-intercept. And how did I get that y-intercept? You take the leading you take the first sign, negative, times each constant. So times negative 1 times 2 times 3, and you get 6. 1, 2, 3, 4, 5, 6. The next one, you forgot their parenthesis. So you would say, okay, the solution is for 4 is negative 4. For 2 is negative 2. And for negative 1 is 1. Now, this is to the first, that's to the first, that's to the second. So this is going to have a bounce right here. Remember, that's where it comes down, touches it, goes back up. Now I'm trying to decide if it starts down or starts up, what it does. So the first thing I would do is I would take 1/2 times 1 times 1 times 1. And if you take 1/2 times 1 times 1 times 1, you don't really need that value. You just need to know if it's positive or negative. Well, 1/2 times 1 times 1 times 1 is positive. That means it goes up on the right. And then the degree, you have x, x, x squared. So it'd be x is x squared is x to the 4th. So that the degree is even. So it's also going to go up because it repeats. And if I wanted the y-intercept, I would take 1/2 times 4, which is 2, times 2, which is 4, and then times -1 twice would be just 4. So I know the y-intercept is 4. So let me see if I remember what's going to happen. It's going to go straight through, and do a bounce. So I think if it starts up, it's going to go down, and I meant to make it go straight through. Something's wrong with my paper. So it looks like a squiggle, but it's supposed to go straight through. And then it's going to go straight through again. It's going to go through the y-intercept, maybe not as a 0. And it's going to go, let's see, down to 2 straight through. Oh, that's 1. Sorry, at the 1, it's going to bounce, so it's going to go and then it's going to go up. So let's go double check this. So it's 1/2 x plus 4, x plus 2, x minus 1 squared. Now that's similar to what my graph looks like. It's not exactly, but the key is the shape. So I need to move this one over a little bit. The y-intercept is 4, but I should move my maximum over a little bit. But other than that, it looks pretty good. So if you look at this graph and then look at that graph, they're pretty similar. I just need to move this over a little bit, make it kind of go up. In other words, I should have done like this, but it's close enough. All right, on this one. So graph, I would say solution for 2 is -2. And it's going to do a bounce. For -2, it's going to be +2. And it's also going to do a bounce. And then what is the leading coefficient? It'd be positive times positive times positive. So 1/4 times 1 times 1 is positive. So the leading coefficient is positive. So it goes up on the right. And then what's the degree? The degree would be x squared times x squared is x to the 4th. So whatever it did on the right, it does on the left. So this one goes up and up. Okay, good to know. So, and then if I want the y-intercept, I would take 1/4 times 2 squared is 4. So 2 squared is 4, 1/4 of 4 is 1. And then -2 squared is 4. So I'd get 1 times 4 is 4. So it's going to have a y-intercept of 4. So it's going to start up here. It's going to come down. It's going to bounce. And then at 2, so it's going to bounce again. So it's going to do something like this. bounce, and go back up. Let's go double check that. Fourth, x plus 2 squared, x minus 2 squared. And notice, mine looks pretty close. I should have put the maximum right at 4, but so I can show you mine. Mine looks a little different, but it's pretty much the same because I'm rushing. So I should have done, can't really see that. So what I should have done was I should have done this. So the maximum is at the y-intercept because it's going to be right in the middle. That makes sense. All right, number 2 is just the same. I see that we're out of time. Down here, what do you know about those things? You'll be okay us not doing that part. So here's what your practice looks like. So this talks about end behavior. This talks about the degree and leading coefficient. So is the degree even? Is it odd? Is the leading coefficient positive? Is it negative? And then be careful. They wrote this backwards. So normally we say as x approaches negative infinity, and then we talk about the function, but they wrote it backwards, which is fine. So this is all in behavior practice. We've covered that before. And then here, you could use a graphing calculator to graph the function. So it's saying that you could type this in Desmos basically, and then just copy down the graph. But here, these are in factored form. So I want you to try to use it without a calculator. Of course, I won't be at home sitting there watching you, knowing if you use a calculator or not, but I encourage you to try to do this without a calculator and then check your work to see if you understand by looking at the factored form how it looks. Okay, but other than that, that's all I have. We are out of time. It's nice seeing you all. Have a great day. Bye-bye.